Hello viewers and welcome back again, and we're still on the software ethical hacking series, and as I told you, we are going to learn a lot in this course. And so today what we're going to do is called Debbuger stepping basic. Debbuger stepping basic. I think we're on lesson 3 for the meantime. So in the previous tutorial, like we did what we set up our cracking workspace and workflow. So today we are just going to dive into the software we installed and know how each and every one works. Okay, so without wasting my time, let's get into it. Now, so what we're going to do today is basically the debugger, which is the X64dbg, the basics you need to know before we get into deep analysis on the software when you are cracking software purposely. So what we're going to cover will be here. Let me show you. I've not saved it. Let me try to maximize this test so that you'll be able to get all we're going to do today. Perfect. So I'm going to introduce you to the command line program, CLI program. Perfect. So we're going to set preferences for the software. We're going to look at the column graph. I told you about this in the previous tutorial. You look at the memory address. You also look at opcodes or machine codes. You also look at assembly codes or the human readable codes. We also talk about the string in comment. Then we talk about what is entry point. We use F1, how to run the program, how to step over in the program. We talk about cause conditional jumps and unconditional jumps for today. And I will show you about the EIP register. Then I'll show you something about the restart. So let's dive into the main course again for today. So now back to my Windows 7. Don't worry about this because it's an overfile I'm using to run this Windows 7. It's not like being installed. I'm running on a VirtualBox to demonstrate everything through this one because I'm working on a MacBook, so I need to run on a VirtualBox so that I'll be able to access our Windows operating system, so that make this tutorial so easy for you to follow. So in this lesson, what you need to do is, well, let me open my software cracking tools. Then what we talk about was this application called the Mexican application, which is untitled e.e, which is the extension here. The exe means this is executable on Windows platform. Okay, so what you need to do is, I will leave this software in the link below so that you can download and follow along. This was coded by one of my programmer friend, which gave me this to try on. Okay, I'll show you sites as a bonus where you can download such applications and try to practice on yourself. It's a legal website where programmers upload softwares for people to crack. Okay, so I'll show you the website at the end of this course so that you're able to go there mostly every time, every day, so that you practice how softwares are being cracked. So the programs always come there, put their software there, and tell you to maybe identify the flag in the place. The flag actually stands for you trying to extract a hash, a serial key, or let's say a password from their software. So they want you to guess the flag which was used in the software. So that is all about cracking. You should guess to get to how to extract those keys from software, so that the programmers will know that okay, when they made the program, there are some other programmers who are able to extract the password, and based on that they can also try the best to maybe patch it themselves, so that it will become so difficult for people to even reverse engineer their programs. So what you're going to do is just select the software and open it in DIE. That's the first program you need to always, anytime you get an application, you just need to load it into DIE first. As I told you, it was called Detect It Easy. Perfect. So what this is going to do is, now let's try to analyze something in this software. I hope you see it. Let me try to expand it so that you see what is going on here. Okay, perfect. I've made it big so that you can see everything going on. Now look here, in the last previous tutorial I told you about the base address, right? So you could see when we load the application into this software, we had the base address, and this is where the program starts from in memory. Okay, this is where the program, anytime you install application on your Windows platform, it goes into memory first. So this is the address in which the software starts. Okay, and now you could see what I was talking about called the entry point, which we are going to talk about more as we compare this to the X64dbg, which we use to crack the software. This is kind of a backup, like we use this to detect what was used. So you could see here, looking at the compiler, the programmer used this compiler called GW GU 4.92, and he used a linker called the GN linker GN blinds console.console. So now we are able to analyze this software perfectly. We know the programmer used a compiler called this and a linker called this, and now we could see the base address and also the entry point address. So to calculate for the entry point of each program, we just add this base address to the entry point, so it will be addition. So add this figure to this, and that is where you get to the entry point of each program. An entry point of a program is where the software is the start. Okay, there's different. So the entry point is where the software starts. Now let me launch this program into our SDBG for you to know what I mean. So when we open this software in SDBG, let's drag it and place it on the software to open it itself. Perfect. Now when I brought the software into SDB, you see that the program was already launched. I told you this is a command line program, so you see we don't see anything right here. The program is running and we don't see anything. But now let's go to the SDBG64 application itself. Now perfect. Let me try to expand it so you see everything going on here. I'm running a whole lot of applications, so pardon me if this is running slow for you. I mean the application. It could run faster on your machine because maybe you don't have anything to do at that moment. So look here, as I told you, this is what the graphical view application. So all this application, these are the codes behind the application, and this is where everything happens. Okay, so here I told you the registry. You could see in the registry we have what we call the EIP, the EDI, all the what the E stand for. It's called the entry interest point. Okay, so this place, as you can see, as I told you, we have the entry point by this EIP is an EDI. So extended interest point. EIP is extended interest. So all this here stand for extended is what meaning. So these are what some of the codes which is being ready, like represent the software in the registry. So it's kind of take it as a code, like let's say you go buy something, or products always have a code. So in the registry, this is representing each code, and what is code right here is the input in the registry of the application. Okay, so looking at these columns, okay, I told you first one is the graphical view column, and this place is what the RAM in memory. So as I told you, when we look at this application, you could see we have what the base address in memory, which is 004. As I told you, when we add this to this, we get the entry. So I'm going to show you that in there. So you can copy this code, add it yourself, and when you get the number, come to SDB64. I'm going to show you something. Before we start, we need to set something we call preference, as I show you here. You need to know the preferences for the program. I've already shown you the column graph, the memory layer with the codes and the machine codes. Now, when we go back to our Windows system and we open the software, as you can see, this place is called what? The RAM address, as you could see, is represented into what? 77 and other numbers. So this is what where the program has been loaded to. This is our RAM, or the memory address where the program is now for temporary use. Okay, so you can see now the program is paused. You can see the information down here. So you see that this is the program is running, okay, but it's being paused. Okay, now when you come to the next column, let me try to. Yeah, perfect. This is where everything happens. Anytime you load an application or you run application, it's converted into zeros and ones. So this is what the computer you are using understand. It doesn't understand this. This is where it works with. That is the, you could see ones and zeros, and here is represented in hexadecimal. So you could see something like EFF70 CE. You know, these are represented in hexadecimal, so you could see some numbers and some also alphabets. Okay, don't worry about that, because that is how the computer converts it when you are working in a debugger like X64, and these are the numbers. So this is what actually the computer understands, and it converts it into the human, or what is called assembly code, or the human readable text for you to see. So here you could see, you can see something like call, push, move. These ones I'm going to show you later on what it means. Move, add, and a whole lot. So you could see a whole lot is going on throughout the software. So you could see that is where the program ends. So all these are behind everything happening in the background of the program. So what this place also meant was what I told about the comments or strings. So here you could see a whole lot of comments here. You can see some other strings here, and a whole lot. Perfect. So the first things I told you that we should set for to preferences. So to set for the preference of this SDBG program, you need to go to options, go to preference, and something is here I want you to work with. So the first thing is event. So I want you to uncheck this box called TL's callback. So uncheck this. You don't need to know the meaning of this, but callbacks is kind of when you're running a program and callbacks and understand, which we don't need at this point because we are going to do cracking issues. So you need to uncheck this so that you would follow the process of cracking, because we don't want any disturbances or the callbacks. It's just like be on your phone and you're trying to call somebody and somebody called your line when you are busy doing some other business with some people. So take it that way in the layman view as I explained to you, because this is depth analysis, so you don't need to, so that you don't get confused. So you just need to uncheck this, and what you need to do is to go to this tab called the exceptions. So the computer says it doesn't know any exceptions for now. Exceptions are the errors that throws into the program when you run the program. So if you run the the DI or the X64 for the first time, I know you came across an error like this. Let's talk about like this. The program can't start because, so these are all what the errors you come across in the program, and that is the reason why we need to set what an exception for the program. So the exception here is to tell the program that it should ignore all errors that we face when we're tracking the program. So in working with exceptions or the errors, all we need to do is we need to set an exception for this program so that any error found it throwback to the application for it to ignore it. So that's why we have the ignore range, we have the delete range, the ignore limit. So in ignoring exception, it always starts from 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, and end at 8 F's. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So after that, just click on OK. Now you could see your exception is being added. Then all you need to do is to save. So with these exceptions, what you're going to face now is any error that your application face, you're not going to get any problem. To be saved, it will ignore it so that you're able to continue all the cracking process. So all you need to do is to save the program now. And now let's try to restart the program and let's see what happened when you restart this program. Perfect. Now you could see the program started from the operating system, and that's not what we need. Now when the program starts from the operating system, we are not here to crack the operating system, we are here to crack the software. Okay, so all what we need to do now is, at this point, we don't need to do anything. You could see here we have what we call the run button. When you run this program, it moves to the entry point. And let's run this program and let me show you something. When you run this program, straight to the entry point of this application. So now look at the comment right here, or the string. You see it has been highlighted. Perfect here. So you could see this is what our entry point. Now when you press F8, okay, or step over, so when you come back to this, I showed you something purposely here, which is F8, which means step over. You can use the function F8, it will go down. Means step over means like going downwards of the program. Okay, so when we come back to the program, all we need to do is when we press on this step over, it will move down one step. Now you could see the 04014E, as you could see here, is what our entry point as it has been shown on the string. So when we go to our detect it easy, as I show you, when you add this to this, you get that number here in the SDBG system, which is 0041, and that is what which is this RAM address, which is what represents as the entry point. So this is actually where our program perfectly starts. Okay, so when we restart the program, it always what starts from the operating system, and as I told you, we are not going to crack the operating system, we are cracking what the software. So we just need to hit on this run or F9. It sends us to the start, which is the entry point of the program, that will be able to crack the software from here. Now, looking through this program, you come across what we call, what I want to show you today, which is conditional jumps and unconditional jumps. Okay, when we come back to the program, just look at where it starts with J. Any J you see is a jump. J, 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 but there are a lot of J's. We have J, MP, J, IE, J, UP, a whole lot of J with a whole lot of other words following how like this. This is JMP, and we have J and E. Also, all these are jumps. So now there is difference between all these jumps. JMP is the only unconditional jump in this application, and the rest are conditional. What do I mean by JMP as unconditional? Take it as like a guy trying to date two girlfriends. Okay, take the unconditional jump as what a guy trying to date two girlfriends. He doesn't look at any condition or test for anything. He just go about. Just take any girl he or she likes. But the rest of the jump, what you do is a test for it compare the two. So you could see here the J and E, which is a conditional jump. What it does is it has a comparison here. Sometimes you use a test. So you see CMP comparison is comparing two figures in the registry to see whether the condition is met. When the condition is met, it decides its decision to see whether it needs to jump or not. But JMP doesn't follow anything. As I told you, it's just like a guy who is the girl he wants. He just go in whether the girl has a big photos or big friends. He just go in and take it. But you see, the other J's always guys look for the condition or how the person should look like. I want the girl with big breasts or big boobs before I can date. You see, wants that lady to meet his condition before he can do something. But the JMP, which is unconditional, what they do is they don't care whether you have big ass or they just date you how you know. Even if you have other stuff as you know, I'll not try to tell you about that in this lesson because we are serious here trying to know how to crack programs. So what we're going to do is since you know now the difference between, I said only the JMP is unconditional. Okay, it just jump to anywhere it wants, and for the other J's you see with other words within, they are conditional. They try to, so before this go jump, it needs to compare these two in the registry to know whether the condition is met for it to jump or not. So if it doesn't jump, it just moves to the next line. It moves to the next line. But for the JMP, it doesn't do those kind of stuff. It just jumps straight away. Okay, so let's look at example here. This program, let's move this program back to entry point. We run the program again. The program is terminated. Let's restart it. Okay, the program is back, and let's move to our entry point. Now you will see down here when we move down this application, as we move we will come across a J. Let's see whether you come across. Perfect. So here, this is our program on title, as you can see here on title. Perfect. So what is happening here? Let's select this. Now you could see this red means this program is going to jump. Okay, so it means before this, I told you this is a conditional. It needs to compare something first before it jumps, because it's conditional. It needs to compare. Hey, do you have boobs? Do you have breasts? For my guy, before I can jump, okay, it compares it to me, and you say what? The jump, you could see here, that's the difference you see. The jump is taking means it's going to jump to something. So you could see after this untitled, there's a figure here 401, which means this program is going to jump to this 40163 in the code, which is what? The RAM or the RAM address. So you could see this is jumping from here to here, and you see it's jumping the red to display, which is 401653. As you can see here, 401653. Okay, and as you this is a condition. It means the condition has been met. Yes, it is okay for this condition. I need to jump. Now let's check for the JMP itself, which is unconditional. And let's see what the moment. Let's try to see one of perfect. You could see this doesn't meet any condition, it jumps straight away to 4065E. so you could see this is the line it moves, so it means it jumped from one place to this place. So when you go, you could see where this is jumping from. You see above it, it doesn't have any condition to me. This is the core just function. This function here doesn't follow any comparison or test to see whether condition is met. As well, there are those guys who just go in for any get they want, they don't check whether they get has a press or something. So that's the difference you need to do. This JMP is unconditional jump, and the rest of the J's are conditional. It needs to compare two things or test for them before they do or perform a jump. So you could see the red means, when you see the red, it means it's jumping from one place there. So you could see here it's jumping rather from here, okay, to this jump to this word. So as you could see in the other jump, the JMP, as you can see here, it's also jump from some place to the other. So you could see the red is, it means it's jumping from a place to the other. Let's try to go up and see where it was jumping from. Perfect. It was moving from this side to this side, as you could see in the program. So that is actually the difference between the jumps right here. One is to compare to condition before it moves, and the other one it just jumps straight away. But in this code, when example, when this condition met and it wants to jump, perfect, you see when we press this F8 or the step over, instead of it to move like the first one, it was moving from line to line. Because of the red line, it will jump to this place. Now let's see when you click on step over, you see step over jumps from that place to this place because of red. So if you miss the place, you can just double click here and go back to where it started from. Cancel. Now this one, I mean this the standard intrusion pointer. When you click on that, it should send you back to where the program came from. Let me try to. Perfect. So this is where we were at first when the program started. So let's restart this program. So it's starting the memory. So the first thing we need to do is to run the program. You guys to move to the entry point. So this is where it was. Let me move to the entry point again. The program has terminated. Let me restart it. We don't need this. Let's run the program to the entry point of the software. Now perfect, we are an entry point. But you see the EIP, as I told you, is the extended intrusion pointer, which means when we move down to any part of this program and we want to go back to our previous where we started, we just double click it, send us back to where we were. So when we come here, let's say we're here and we are lost, we just double click, we are back to the entry point. As you could see, it has been highlighted here. When I move this cursor up, you could see we have the highlight, which is the other entry point. Let's move down a bit with the step over, and now you can see this is the entry point I was talking about, where the program itself starts. And that is where when you are beginning your Kraken, you should always look at. Not when we restart the program, we don't use the one that starts with 7, or this is where the operating system starts the program, and that's not what we need. We don't need to crack the operating system, we just need to crack our application. So that's what the complete introduction of how these jumps and the function of core. As we get into the knowing how to know about these calls and other functions. But let me show you something. After this, the program wants us to do something, so we are going to run this program from the command line, and let me show you something. So let me close the program first. I hope it's closed. And now go to your start and type in cmd. And let's open the command prompt. Perfect. Let me close the application. Okay, let me close the debugger or the debugger. Yes, I want to close. We don't need you again. Let's close I want to show you something now. To run the program from the command line, because a command line program, you can see untitled.exe. Now to open this program, we just need to change directory cd, and which directory are we moving into. So all we need to do is to, the software with this, you copy this link anytime you open a folder. So this was the folder we opened. When you open this, you see top here. Okay, all you need to do is to copy this by selecting it. And so sorry, the computer restarted, but we are back again. I'm going to show you how to run this from the command prompt. I think I was just typing a lot of command that made the computer restart itself. So this is the program, which is untitled.exe. I said I'll leave it in the link below so that you'll be able to download. But let's go to our CMD. Search for CMD. That's how you run a command line program. Now all you need to first, you need to type in cd, which is change directory. Then to make this program very quick to run, you see on top here, you just click here. It will select the program for you. Then now you can right click on the program to copy it. Copy the program and just come to paste it here. Perfect. So now you see it pasted my application right here, and when I hit enter, okay, let me try to maximize it so that you see. I hope this will be very big enough for you to see. No, it's still I need reduce it so you could see what is going on. So with this, what we need to do is just hit on dir, which is the directory we are in, and perfect, we are here, and you see the program is untitled, and this is the size of the program. And now to run the program, all you need to do is just type this name here, just type the first word of the program and just hit your tab key. It will complete the program for you. The tab, then hit enter. And now I told you this program wants us to crack it because it has something hidden in this application. You could see it's saying try harder, okay, which means the program was not able to give us the hidden information within this program. So we need to use XDBG to crack it, to reveal what is really hidden in this application. So it could be serial key, it could be password, it could be anything. So that is purposely how to crack this application. So the best thing, as I told you, this is a debugger or the deassembler, which will help you the program to be effectively cracked within some couple of seconds and couple of minutes, depending on how the program was programmed by those programmers. So that is actually the information which is given us. You see, we should try harder to guess and to be able to review the information behind the application. So in the upcoming tutorial, when we will be talking about cores and other stuff, so that you get in-depth analysis on how this is going. So before we end this, of course you get a whole lot of knowledge of what is going on anytime you run a program. So you should now know about the RAM, where anytime you run a program on your computer, it goes to a RAM location, which is represented by those addresses 0041. And now you know what we call the computer code, the opcode, or the other code, which gives you the binary, that is ones and zeros. And we also know about the human readable text, where you get information about how it's represented to the human for it to be readable to us. So that brings us to the end of the basis of this debugger. Now you could see the differences of what we are going to cover along the way. I hope you enjoyed this tutorial, and in our next lesson, as you could see, we'll be going through this, what we call stepping into cores. So we're going to know about our cores function, how to call the programs, and also we'll be talking about breakpoints too. So I hope you enjoyed this tutorial. Stay safe, be good, try to share this video, hit the subscribe, and let's enjoy learning together. As you could see, it's always learn with your brains. and I hope you've learned something new today. At least if you don't know, you know how programs are run and memory and a whole lot of stuff. Okay, take care, and I'll see you in the next lesson when you talk about stepping into course. Okay, goodbye.